Okay, here's a little video tutorial on how to use Hess's law. So given the following data, find the delta H of the following reaction. So here we are given three equations and they all have a separate delta H. And we're going to have to rearrange these reactions to come up with an overall reaction. And when we change something in the reaction, we also have to change the delta H associated with it. So let's first look at our overall reaction and kind of find it within these reactions. So let's start with carbon. So here we can see carbon, and let's find it, and it's right here. So if we take this down, so it's reaction 3, we see that we have 2 here and we have 1 here. So we're going to have to divide it by 2. And because this is on the product side and this is on the reactant side, we're also going to have to flip it. So I'm just going to write flip. Now let's go to oxygen. So oxygen, we can find it in 2 places, 2 and 3. So we're just going to skip it for now, but we'll come back to it. But let's move on to carbon dioxide. Carbon dioxide. And we're going to find that over here. So what we're going to do is reaction 1. And here, all we have to do is flip it once again, because this is on the product side and that's on the reactant side. Okay, so I wrote out our equations with the changes. So number 1 is flipped, and number 3 is divided by 2 and flipped. Okay, so let's do the same thing to our delta H's. So our original one was negative 234, and we're going to have to negate that, or switch it. So we're going to get plus 234, and then for this one, we're going to have to divide this by 2 and also change the sign. So we're going to end up with negative 1,220. Okay, now to see what we get for equation 2, we're going to have to attack it with, well, there are multiple methods in which you could figure it out. So, well, we could figure it out doing this. So let's say, okay, so we want to end up with 1 oxygen. So let's look at the oxygens that we have. Okay, so we have 1 oxygen here, and if we add that to that, we're actually going to be minusing it. So we're going to end up with 1/2 oxygen, which is not what we want. So we can also look at it with the strontiums. Are these going to cancel out or not? So we can do, so we have 1 strontium here and 1 over here. So those don't cancel out, because if you add these together, you're going to end up with 1 strontium. So it doesn't cancel. So what we're going to have to do is divide all this by 2. And luckily, we can just go like this. And 1/2. So let's do that to the delta H as well. So our original was 1,184. So what we're going to get is 592. And the sign remains the same because we can flip it. Okay, now because we have to make sure that everything kind of cancels out. So our strontium cancels out. Let me look for a different color here. These cancel out. What else cancels out? These cancel out. And then we're left with C plus this will equal to 1 oxygen, so plus O2 is equal to, our last one is equal to CO2. Okay, now that we have the original equation, we just have to find the delta H value, or the overall reaction delta H. So according to Hess's law, we're going to have, so delta H, and, that's right, is going to be equal to the delta H value of equation 1 plus delta H value of equation 2 plus delta H value 3. Okay, so if we take our values there, we're going to have plus 234 joules, uppercase J, plus 592 kilojoules, plus negative 1,220 kilojoules, and then that's going to equal to negative 394 kilojoules. And because it's a negative, so that right there is our overall reaction delta H. And because it is a negative, it is an exothermic reaction. And that is our answer.